In lesson 7.3, we're going to talk about compositions of transformations. And we can perform the previous transformations, which were quite a few in section 7.2, in a row to get something called a composition of transformation. So for example, in this diagram that we see here, we notice that we have an original light blue triangle. And this light blue triangle has moved 3 units to the right, as is evidenced with the x plus 3. And then we see that this same triangle has been moved 4 units down, which is y minus 4. Now we could write these as 2 separate transformations, or if we want to, we can write a rule that tells us what happened. And the rule is that we had the y minus 4 from the second transformation part and the x plus 3. And then of course we had our original figure in the light blue. That was our x and y, our x and y coordinates that we originally started out with, whatever those were. And we used both the orange transformation of horizontal adding 3 and the pink one of going vertically down 4 and put them as one rule. So down below here, what we see is the one rule, xy goes to x plus 3, y minus 4. That's called a composition of transformations because there's more than one. It doesn't have to be 2 different style of transformations. In this particular slide here, we see that we do 2 things as well, but they both happen to be in the same direction. So when we look at our original figure of x and y, what we see is that the xy this time has 2 things that have happened to it. It has the going 3 to the right originally, and then it also has going 3 to the right again. So that means you had x plus 3 both transformations. But then when you put them together, what you see is instead of writing them separate, you can just go x plus 6 because you move to the right 3 and 3 more for a grand total of 6. So your transformations, or your composite transformations, can be 2 in the same direction if you want them to be. They don't have to be different. You just still combine them. Plus 3 means plus 6. So our rule becomes xy turns into x plus 6 comma y, because we've moved a grand total from the start of 3 units to the right and another 3 units to the right for a grand total of 6 units to the right. Something that's really interesting, and there's not really any formulas going on here, but just something interesting to notice, is that if you take a certain figure like our light blue triangle on the left, and you make a reflection over this green dashed line here, you see that reflection over the first line. But if I draw a parallel line to that original green line, so here's that parallel one, again in green, and I reflect the dark blue triangle over the second parallel green line, I end up with a translation that's twice the distance between the parallel lines. What does that mean? So first of all, I reflected across this line, and then I reflected across this line, and in the end, the distance is twice between the parallel lines. What is that saying? It's saying that if I look at how far did this point travel from here to here, and I tell you that that is 10 units going from peak to peak, light blue to green triangle, that this distance in here is 5 units between the parallel lines. So the amount of translation is double the distance between the parallel lines. Kind of an interesting fun fact. In this last slide for this section, what I want you to notice is that reflections over 2 intersecting lines becomes 1 rotation. So 2 reflections becomes a rotation. That's twice the distance of the acute angle. So and again with the twice thing. So let me show you again what this means. First of all, here's a reflection once over this line. Second, here's a reflection over this line. And what they're saying is, if I look at the angle that's right here, let's say that this angle was 30 degrees, then the total rotation from the original triangle to the last triangle will be 60 degrees. That's what this rule is saying. So two lines that intersect, reflection, reflection, turns into rotation twice the angle between those intersecting lines.